Hello everyone, welcome to CBTanytime. My name is Miraj Tanvir. We will be covering networking basics, especially the OSI reference model and the TCP/IP models within these slides. In 1980s, the PCs that we bought off the shelf were not network aware. So here I have PCA, and very next to it I had PCB. Back in 1980s, these PCs could not communicate with each other, and therefore we used to call this a stand-alone environment. In order to make PCs network aware so that they can communicate with each other, we had to install these cards when they came out. These cards are known as network interface cards. I believe that's a great acronym because it's a card that allows the PC to interface with the network, thereby making the PC network aware. So back in those days, all we had to do is when we bought the PCs, we used to buy these NIC cards, plug them into the motherboard, install them in the motherboard, and they became network aware, and they could then communicate to each other by running cables to each other or by running a cable to the centralized device like a hub. So what's important about these NIC cards? Why do we use them? How does they make the PC network aware? All cards in the world are unique. They are unique because every card has a unique number called the MAC address burnt into it by the vendor who created it. These MAC addresses, which stands for media, access, control. So it's an address that will allow the PC to access the media. I've made some good acronyms there. So this MAC address is a 12 hexadecimal digit number. Now you might ask what hexadecimal digit numbering is. Hex numbering is from 0 to 9 and A to F. If you want more information, I would suggest just Google hexadecimal digits and you'll find a lot more information about this. So this could be an example of a MAC address. Look at this. These are 12 hex digits. In terms of bits and bytes, these MAC addresses are 6 bytes or 48 bits in length. We all know that 1 byte equals 8 bits, and therefore 6 bytes will equal 48 bits. Because this is the only unique number from a networking perspective on the PC, all communication must happen on this MAC address. So here, if PCA wants to communicate with PCB and it does not have the MAC address of PCB, they can't communicate. As simple as that. So here we've got some examples. This is a wireless NIC card. This is an NIC card to be installed in your laptop. This is a wireless adapter from Cisco, and this is your normal LAN NIC card here. All right. The important thing to understand is all these three cards will have unique MAC addresses that will make them network aware. Let's talk about OSI reference model and how is it important and what it covers. To give you the background, I would give you an example. Today, in 2012, I can go to any country of the world. I can go to Russia, I can go to Ghana, I can go to Germany, I can go to USA, I can go to Australia, I can go to India. And I know that there is one language that will help me get my way through. That language is known as English. We use English every day. This video is in English as well, by the way, isn't it? So similarly, today I can walk to any PC of the world, may it be running Unix, Linux, Windows XP, Windows Vista, Windows 7, Novell, Apple, whatever operating system it's running, I know that there is this computer language, this protocol that all these PCs must support, and that's known as TCP/IP. Now, to go through the OSI reference model and to explain it in detail, I want to give you an example. Imagine 200 years ago, person A was born in China, and the law in China said no one comes into China and no one will be allowed to go out of China. So if you're born in China, you stay in China for the rest of your life. That's pretty cruel, isn't it? But anyway, and similarly, this guy B was born in the UK, and the law in UK was pretty much the same. No one comes into UK, no one goes out of UK. So if you're born in UK, you stay in UK for the rest of your life. So my question to you then is, could you then get this guy A to communicate with this guy B in UK? Can you? Can they talk to each other? Do they know each other's language? Do they know each other's dictionaries, the alphabets? No, absolutely not. So these guys could never communicate with each other. That's the same thing that happened in the networking world as well. In 1970s, you had no networking protocols. You had vendors like IBM. They created their own protocol known as Systems Network Architecture, SNA. That was their architecture for the mainframes. But no one knew how SNA worked except for IBM and except for IBM PCs, except for IBM mainframes. Similarly, you had DEC. DEC had created their own protocol known as DECnet, but it was a closely guarded secret back in those days. So I don't know if most of you have heard the word locked into a single vendor solution. That's what used to happen in early networking days. If you bought an IBM, you always had to keep buying IBM because only IBM PC could speak to IBM and only DEC PCs could speak to DEC. In these circumstances, the end user suffered. So the IT industry realized that they need to standardize data networking and there needs to be a model that every vendor can adhere to. So therefore, these different vendors can communicate to each other. So to join in and create this noble task, they created this organization known as ISO, International Organization for Standardization. They have done some fantastic work with these acronyms here. It's an organization bent upon standardizing. So this organization was born in or created in late 1970s. And when they were asked the question, how are you going to standardize this networking? It's so disparate at the moment. These guys said, you know what? We are going to create a reference model known as OSI. It will allow all systems of the world to interconnect. So OSI actually stands for Open Systems Interconnect. And this is going to then standardize data networking. Now, this was out in the open. This was in the news. This was in technology magazines back then. But in the background was US Department of Defense as well. They were also working towards a goal. Their goal was not to standardize data networking, but their goal was that America had recently come out of Second World War, and they expected the Third World War to happen. And they expected the Germans and Russians to retaliate. So Department of Defense had disparate networks, and they wanted those networks to communicate with each other. So it is actually the Department of Defense that created TCP/IP protocol that we use today as a part of their DARPA project. Now, details about DARPA project are not important for this discussion, so I'll just leave it and move on to other important things. So, what did ISO ended up creating? What is the OSI reference model? Ta-da! There it is, the OSI reference model. I must highlight this thing. It's a model. You don't go into any computer shop and ask them that you want to buy a PC with the OSI in it. So this is a model. There's no hands-on, there's no support on it. It's a 7-layer model. So you've got application, presentation, session, transport, network, data link, and physical. So as you go up the model, you will find that the intelligence will increase. And as you go down the model, of course, the intelligence will decrease. This is where the user sits. This is where you and I sit and we use Google Chrome or we use Real Play or we use Internet Explorer and we see the pretty pictures. And this is where your cables and wires are. So intelligence will increase as you go up the model and it will decrease as you go down the model. And another important thing I want to highlight over here is that you've got layer 7, that is your application layer. It's not layer 1 that is your application layer, all right? So some people do get that confused when they go into exams and stuff. So layer 7 is application and layer 1 is physical. How do you remember this is my first question. So in order to remember this, some people use the mnemonic, all people seem to need data processing. All people seem to need data processing is a very common used acronym. And what you'll find is that out of these layers, 5, 6, and 7 relate to application functions. We at CBTanytime call them executive layers. I'll talk about this later in my other example. And it is actually layer 1, 2, 3, and 4 which these layers actually get your data from one PC and actually deliver it to the next PC. So we call them worker layers. Now, quickly talk about TCP/IP model. Please understand the TCP/IP model is not is not created to standardize data networking for everyone else. This is only a model for themselves. So instead of having the 7 layers that OSI reference model has, TCP/IP layer model has only 4 layers, and out of that you'll find the application layer will incorporate the functions of application, presentation, and session into one layer. Transport is known as transport, network is known as internetwork, and the functions of data link and physical are amalgamated into one layer over here called the network interface layer. I understand most of you might know these layers as well up to here, but it is the understanding of what each layer does that's sometimes very hard to explain. So we at CBTanytime will do it using the easy OSI reference model. Now, CBTanytime's easy slides have been specially created to make the topic easier to understand. These slides may have some minor differences from the real world, we understand that, but these should be ignored to understand the crux of the topic or technology. And over here, while we are explaining the OSI reference model, we want to discuss a standard delivery model. So what I want to talk about over here is these videos have been created in Australia, and there is this company known as Mount Franklin. Now, Mount Franklin make mineral water. And what we find is that, let's suppose if I was the CEO of Mount Franklin and we were delivering mineral water to our customers, we found that sometimes it was very hard because when we went out to deliver mineral water to one of our customers, they would say, all right, you go into the basement because that's where our delivery department is. When we used to go somewhere, there was no standardized method of providing insurance, or if a company did not want insurance, there was no method to do that. So what I did as the CEO of Mount Franklin in this example, I got all my customers together and we wanted to standardize the networking, the delivery model. Let's look at what we did to create that.